Good evening, my dear warriors. Welcome to the next session of Momentum and Collisions. And today we are going to discuss head-on collisions, coefficient of restitution, and also oblique or collisions in two dimension. All right. In previous session, I have already explained what is momentum, what is impulse, how do we use graphs and even derivatives or calculus to find average forces, right? And we have also seen how to apply the law of conservation of momentum, where we studied that, if from outside the forces are balancing each other, they are cancelling out each other. So external force is zero, then the entire system preserves its momentum before the collision, after the collision, before the explosion, after the explosion, or whatever is before and after scenario, the total momentum will be conserved, right? Whether it is 1D, 2D, 3D, whether it is any kind of collision, doesn't matter, it will be conserved. And we have solved some questions on that. So if you have missed that class, please check out the lecture on the channel itself, right? On the Vedantu JEE English channel, guys. There are playlists and beautiful sessions planned just for you. Yeah, you have done this particular lecture already. Okay, so let's begin. Hi, it's me, Princess Rama. Welcome, Hema. Logesh, hi, Kirti. Welcome. Jayashree, welcome. Everyone. Yes, nice to see all of you out here. Great. Welcome, guys. Welcome, guys. Right. So let's begin the class. And this is my introductory slide. In case you are new to the channel, say hello, hi. Yes. And let me know where you guys are from, whether you are 11th or 12th or a dropper student. Okay. And yes, if you're not yet subscribed, please do that and like the video. Cool. Hi, Malini. Hi, Ojit. Welcome. Welcome. Great. Let's begin then. Let's begin. All right. Okay. So let me first start. Oh, by the way, I hope you have registered for MVSAT. In case you haven't, this is a reminder slide because exam is very close by 4th, 5th, 11th, and 12th of October. Okay. Obviously, prizes are there, scholarships are there. Plus, you'll get to meet us, and also, yep, you're going to get to know where you stand. A lot of kids are going to write this examination. Cool. Yeah. So better give this exam. Hi, Logesh. Good evening. Good evening. Now, BTech, I'm from mechanical. Yes, I did my BTech in mechanical engineering, although it was not at all related to whatever I'm doing in life. And most of the people will tell you, whether they are from IIT, NIT, BITS, whatever they chose the branch, they are not doing anything related to that. 99%, not even 80% or 60%, 99% of the people never do whatever they opted for. That is why college is more important than the branch. Okay, so let's begin with the lecture. Okay, so first let me tell you what is head on. It's like, imagine there is an angry bull. It gets very angry because I'm wearing a red t-shirt. It gets charged up and comes running towards me and does dishum. It hits me directly and I go flying off. That is like head on collision. Yeah, or two goats, they try to fight, right? Or rams, they call. You might have seen goats fighting with each other, right? They go back and they go like this and they hit their horns, or they lock their horns. You might have seen that, right? So that is head on collision. Or if you have seen pool or snooker, this is a table, this is that cue ball or that striker ball, this is that stick. You aim and you hit that ball, the striker ball, and it hits another ball which is numbered. It will hit it and this ball will go straight. So everything is in a linear dimension, one dimension, right? Or then it is called basically a head on collision. It's basically a 1D collision, simply put. Okay, is that absolutely clear, everyone? Okay, great. So in head-on collisions, first of all, I can mention this is nothing but one-dimensional collision, one-dimensional collision. And the most important thing is this diagram. Observe it very carefully. Okay, observe it very carefully. This is one of the ball. This is that other ball, maybe M1 and M2. So this is during the collision, during the collision, so they are colliding. Keep this in mind. This ball will apply a force on this ball, this ball will also apply a force on this ball. So if I show the forces which each ball is applying on the other, here is how it will look. This ball has applied a force on this ball like this, has applied a force on this ball like this, and this pink ball has applied a force on this ball like this. Both these forces, both these forces are going to be equal and opposite. The force of collision, the forces of collision, the forces of collision are equal and opposite. Opposite. How do I get it? By Newton's law of motion, the third law of motion. Obviously, the forces will be equal and opposite, and they act for the same time. And they act for same time. Obviously, as long as they touch each other, that is the time. Ball 1 touches ball 2, ball 2 also touches ball 1. So for the same time interval, they will touch each other. As a result, what will happen? Force is same, time is same. Force into time, what is it called? Impulse. Remember, Newton second. Force is Newton, second is time. Newton second. Force into time is impulse, the change in momentum. So the impulse ball 1 applies on 2, or the impulse which ball 2 applies on 1, is going to be the same. Therefore, I can conclude that the impulse is equal and opposite. Impulse is equal in magnitude but opposite in direction. Opposite in direction. That's it. This is absolutely clear, everybody. During any kind of collision, the impulses magnitude are same on the colliding bodies, but they are opposite in direction. So vector wise, they are not same. They are just opposite of each other. Right. Now, no, it is not one shot, Manda. It is a detailed class. We still have time. We definitely are doing the detailed classes. Okay, especially the mechanics part, I want to do it detailed. Okay, other things, low voltage, fine, we can do it little faster. Now, the next important thing is momentum is also conserved. So I will also mention conserving momentum, conserving, conserving, conserving momentum of the system. What I can say is that the momentum before is the momentum later on. So m1 u1 mass 1 into velocity 1 plus mass number 2 into velocity number 2 before the collision. U is before, v is the symbol which I use for afterwards. So this is after the collision. So this ball went and hit this ball. So after the collision, maybe they will move with some newer speeds v1 and v2. So that will be equal to m2 m1 v1 plus m2 v2. Okay, so why have I put a bar? Because that is a vector quantity momentum. So if any of the velocities are in some other direction, I might have to use minus sign, plus sign accordingly. Also, if it is in 2D also we can use it, because then I can write velocities as I cap and j cap. So this is a more generic equation, not just for 1D, even for 2D or 3D also you can use it. As long as you stick to I cap, j cap and k cap, or you can split it in components and solve it separately for x, separately for y and separately for z. Okay, this much is clear, very simple. All right. Now, sir, is it the same for non-rigid bodies? Yes. Whether it is rigid, non-rigid doesn't matter in these examples, because momentum is not dependent on the rigidity of the bodies. Momentum conservation is just dependent on whether the net force is zero externally. So if it is zero, whether it is rigid, non-rigid, soft body, water, air, molecules also, it will be valid. This is valid even at the cosmic scale. Galaxies are colliding, planets are colliding, or even two atoms are colliding. Whether liquid, solid, gas, doesn't matter. So this is a universal law and it is applicable everywhere. Okay, Rama? Great question. So let's solve this. This was asked in JEE 2023. A particle of certain mass moving with certain speed collides with a stationary mass of 2m. After the collision, they stick to each other and they continue to move together with what velocity? Whenever you have to solve the collision problems, better draw the diagrams first. So we have a particle of mass m and it is moving with a velocity v, and there is another particle slightly heavier of mass 2m, but that is at rest. Now this is before the collision. So I just show something like this to represent this is before. So what is happening afterwards is that both of them stick to each other. So once they stick to each other, their total mass will be 3m and they will have a new velocity. I will call it as v1. So question is, can you find that new velocity? So let's conserve the momentum and see what do we get. So conserving the momentum. So initial momentum will be mass into velocity. The other guy is at rest, so plus 0. The final momentum will be the total mass finally into the new velocity. It's obvious that m gets cancelled and v will be equal to 3 times of v1, or v1 will be, take that 3 down, so it will be v divided by 3, which is the third option. Very simple. This has come in JEE 2023. But JEE 23 and 22 was actually simple. Yeah, but it builds that confidence. Correct? Very good. Awesomeness. Everyone got it? Perfecto. Yep. And everybody should spam the answer, not just 1 or 2 students. Everybody should spam the answer. Great, great, great. Now that we have understood, we have done these kind of momentum conservation problems, by the way, in the previous lecture. In case you have not seen, please watch this video till the very end. Okay, because we have done this conservation of momentum related. Lot of questions I have done. Pandu is jumping on the card, Pandu is coming out of the card, all these kind of questions, bullet striking a box. Okay, this we have done it, many types of examples we have done. Okay, so just check out that class. So it was more like a recap, I would say, what we have done right now. Anyways, now let's come to the main topic of discussion, and that is the types of collision. Why do we have different types of collision and what is the significance of it? See, momentum is always conserved, but energy is not conserved always. So based on the energy aspect, we divide the collisions into different types. Okay, I'll just repeat it over here. As long as external force is 0, as long as external force is 0, momentum is always conserved. Momentum is always conserved. But there is a but energy may not be conserved. So based on this energy, how much it is conserved, how much it is not conserved, we are classifying the collisions into different categories. Okay, so what are those 3 categories? I will tell you one by one. Okay, what are those 3 categories? Let's see them one by one. The first type of collision is called as elastic collision. Elastic collision, number 1. This is the first type of collision. The second type of collision is called inelastic collision. Inelastic collision. And the last type, third type of collision, is called perfectly inelastic collision. Perfectly inelastic collision. These are the 3 different types of collision. What is so special? What is the difference? Don't worry, I'll tell you everything, but first I'm telling you the names. Elastic, inelastic, and perfectly inelastic. Lot of people think there is something called as perfectly elastic collision. Guys, there is nothing like perfectly elastic. If it is elastic, means elastic. Nothing like imperfectly elastic, perfectly elastic. Don't remember such stupid names. It is just elastic collision. Only in inelastic collision you have just inelastic versus perfectly inelastic collision. Okay. Once I explain, you will understand it and you will not forget it. Okay. Now you might have seen lot of clothes. They have elastic in it, or rubber band. Yes, everybody has seen a rubber band. We call a rubber band as elastic. Why rubber band is called elastic? What is the meaning of the word elastic? Elastic means it regains its own shape, size once you deform it and let it go. You pull the rubber band, you have deformed it. Leave the rubber band, comes back. Pull the clothing, it will get stretched. Leave the clothing, it comes back. You might have seen elastic pants, right? You pull that pant or your half pant, right? You put that half pant, it expands. You leave that half pant, it comes back. So that is elastic. So elastic means it should regain its state after after letting go, or after letting go of the deforming force, after letting go of the deforming force or the deformation. So it has been deformed, you let it go, it comes back. That is elastic. They say, no, the tail of a dog is like stubborn. If you see the dog's tail is like this, you twist it, it will come back. You twist it like this, it will come back. You take it like that, it will come back. So the tail of the dog. So to tell the character of a person is very stubborn, we say his character is like the tail of a dog, meaning it's elastic. No matter how much you try to convince, put pressure, again that person will come back to his or her original behavior. Is that okay? Hi Dilip, welcome. Abdul, I hope it is clear. Frederick will be letting you know very soon. Yes, Manda, I know we are very close to 300K. Right. Okay. Now, what is the meaning of inelastic in general? Inelastic in general, perfectly inelastic or inelastic means it is not elastic. That means it will not regain its shape, size, state. So, like imagine somebody punches me, dham. Okay, I go like this in slow motion and then again I come back. That is elastic. But somebody punches me like this, dish. I go like this and I look like that and I am like this only. That's it. That is inelastic because I'm not coming back to my original state. Getting my point? So if I bend something, I leave it. It stays like that. It is deformed now, gone. Permanent deformation, change of shape, size is there. That is inelastic. So inelastic means there is a permanent deformation which occurs. Permanent deformation which occurs. That is inelastic behavior. Is that clear? Okay, I will come to the kinetic energy aspect. Don't worry about it. Okay. Now that we have spoken of, we'll come to perfectly inelastic in a bit. Hold on. Now that we have understood what is elastic behavior versus inelastic behavior, think about it. There are two bodies, okay? Some two objects. They'll collide. And after the collision, I tell you that the collision was elastic in nature. What can you conclude from this? Oh, the bodies collided and the collision was elastic. That means they regained their own original state, shape, size, whatever. That means, can you tell me something about the energy? I don't think energy would be lost because there is no deformation, there is no permanent damage, there is no pieces which broke off during the collision, some dust came, nothing happened. I didn't even hear that collision. So, no sound loss, no sparks came, no heat was generated, no breaking happened, no deformation happened. Basically, there will be no energy loss. No energy loss. That kind of collision is basically elastic collision. Can we think of some example of that? Can we think of some example of an elastic collision? Why not? Imagine atomic collisions, or I would say subatomic particles colliding with each other. Subatomic particles collision. Subatomic particles collision. Like proton is colliding with another proton. One proton is moving, wandering, another proton comes here and they see each other. They start repelling, they come close, repulsive force becomes strong, stop, and they go back. Will you hear anything? Even at a minute level? No. Will there be heat? No. Will there be deformation of the proton? No. Will there be some light? This, that, nothing. So the two protons will come like this, they will repel and go back. So that is elastic collision. So you might think, sir, only elastic collisions will happen at subatomic level, sir. Nothing like that. They can happen at a good level, micros, not only microscopic, normal, day-to-day life also. Like you might have seen that crazy rubber ball. You throw it on a wall, zoop, it comes back. You drop it from a height, it comes back till here. Have you seen that rubber ball? How many of you seen that kind of a rubber ball? You drop that rubber ball, it almost comes back to the same height and it keeps bouncing, dab, 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 many times. So that is almost elastic collision. So that crazy rubber ball, I don't know, we used to call it the crazy rubber ball. If it has some other name, you can give that Gen Z name as well. So crazy rubber ball. So they are not really elastic because there is some sound which you hear, and after some time it will eventually come to a halt. So it is not perfectly or that great elastic collision, but it is almost an elastic collision. In reality, no collision is absolutely like ideally elastic. Always some kind of energy loss will happen, but only at the subatomic level the collisions can be actually truly elastic in nature. Okay, but in reality, if you see anything colliding, even if you don't hear anything or don't see any heat or deformation, minute heat might be lost, but if it is negligible, then we consider it as almost elastic collision only. Yeah, okay, clear? Very good. Yes, thank you, Abhinav, so much. Thank you, means a lot, means a lot. In inelastic collision, like I said, permanent deformation occurs. Permanent deformation occurs. So definitely there is energy loss. There is definitely energy loss in the form of heat. Sometimes sparks might come, light will come, some breaking might happen. It might break into pieces, or maybe, some kind of deformation might occur. So all sorts of things, it might deform, and so many other kinds of losses might happen. Most of the collisions around us are inelastic collisions, like two vehicles in an accident. Vehicles in an accident, right? It is definitely inelastic collision. This vehicle hit this vehicle, that vehicle got a dent, sound, right? Some heat, sparks, everything came. Boom, they collided and they went somewhere, right? Two trucks colliding and they bounce off each other, or one went into the other. So those are inelastic collisions, right? Even a normal ball hitting a bat, a normal ball bouncing, normal ball bouncing is definitely inelastic in nature. I hope this is absolutely clear. So now that we understand the difference between elastic and inelastic, let me show you the energy graph. This is something which very rarely I have seen any teacher showing it. So I'm going to show it to you, but this is obviously very important from JEE perspective. Okay, so let's see that. So this is elastic, this is inelastic. What is this? This is energy graph. So on the y-axis, we'll have energy. On the y-axis, we'll have energy. And here we'll have different states: before collision, after collision, during collision, and all of that. Okay. So first, before collision. So first is before collision. Let's start with elastic behavior. The graph will be a straight line. Nothing. Okay. Nothing happened. This is just simply before collision. This is before collision. Nothing happened. The energy was constant. They have not yet interacted with each other. Same thing over here also. This is again before collision. This is before collision. Now what happens? They collide. Once they start sticking to each other, they start touching each other, there is some temporary deformation or permanent deformation which might occur. So during that, what happens is you will see that the kinetic energy might go down a little bit only during that phase where they are touching or interacting or applying forces of impulse on each other. Only during that time you will probably see that their kinetic, we are talking more likely of the kinetic energies, their kinetic energies will go down for some time. Their kinetic energies will go down definitely for some time like this, but it will again come back. But over here, you will see it will go down, but it won't come back so much. So this is what happens during the collision. This is during the collision. This is during the collision. During the collision. And you will see after the collision, it will be back to its original state. In case of elastic collision, this is after. This is after collision. As you can see very obviously that there is no change in the final energy, kinetic energy versus initial energy. Final energy, kinetic and initial kinetic energy is the same. Only temporary, some small change was there, but it again regained it back. So that is why there was no energy loss. This is perfect type of collision where nothing changes before and after energy wise. Okay. Only in case of inelastic collision, which is a more realistic kind of collision, definitely if you see now the final energy, you will see definitely it will be less. This is after. This is after. And we can definitely check out the loss levels over here. This was before, this is after. You can see this much has been lost. This much has been lost. This is the loss of energy. Is this absolutely clear? Everybody with me? Yeah. Is collision significant? Definitely. Most of the questions from this chapter are from collisions. Okay. Hi, Ramya. Welcome. Now only I came from school. Yes, we just started couple of minutes back, but you can definitely catch up, William. Even if you go back and catch up at 2x speed also, you will definitely understand it. Okay. I've gone very systematically. Okay, sir. Sir, one thing remaining perfectly inelastic collision. This is the worst kind of inelastic collision. What happens in inelastic collision was energy is lost. But what can be a best or what worst, you can say, kind of inelastic collision? Here, maximum energy is lost. Maximum energy loss happens. Energy loss happens. And you will see the bodies, excuse me, the bodies move together after impact. After the impact. That is what a perfectly inelastic collision is. Example, two balls collide and stick to each other. Or imagine a embedded bullet embedded in a block and moving thereafter. Moving thereafter together. So all these are examples of perfectly inelastic collision. Two balls are there, get stuck and they move together. Or a bullet is there, it hits a wooden block and it is inside of it, it is embedded in it and they move together. So that is again a perfectly inelastic collision. Here, how will the graph look like? Let me show it to you. So this is energy versus the duration. So again, I'll show kinetic energy over here. Kinetic energy. You will see this will be before. This will be before the collision. During the collision, you will see that the energy will be lost. So this is during the collision. This is during the collision. And after the collision, you will see it will not try to recover also. Maximum loss will happen. So this is after the collision. This is after the collision. And as you can see, maximum energy has been lost. If you compare it with the previous one, at least it tried to recover something. No, it will, lose as much possible energy, it can. Beyond this, you can't lose further energy. That is the significance of a perfectly inelastic collision. Yeah, definitely, Umar. You can definitely watch my lectures for 2027 NEET JEE. Definitely. These lectures are one of the finest lectures which you can get on YouTube, right? Okay, my board has stopped responding for some weird joy. Hold on, guys. Now, every now and then it has. Luckily. Okay. Hmm. See, here the loss was not so much. Here the loss is maximum, right? So that is why it is perfectly inelastic. Maximum loss has happened. Okay. So I hope the difference is absolutely clear. Let me know quickly in the chat box by giving a thumbs up. Elastic collision comes back to the original state. Okay. And initial energy is equal to the final energy. In elastic collision, the final energy is less than the initial energy, but there is some heat, light, sound loss. In perfectly inelastic, there are losses, but that is maximum. You can't go more than that. And the bodies move together as a single unit, right? Hi, Kaushik. Welcome aboard. Clear, Rama. Very good. Now, is there some parameter to decide how bad or good a collision is? Sir, is there some number which will tell me this is elastic collision, this is inelastic collision, but in inelastic also it might be little inelastic, more inelastic, or perfectly inelastic? Is there some number which can be used to judge the nature of the collision? So that is what Newton did back in the days. He was having so much of time. He did not have to prepare for JEE, NEET, CUET, this, BITSAT, VIT, nothing, no exams. So he was pretty chill, bro. And what happened is he tried experimenting with different pairs of bodies, different speeds, one marbles balls, then he used granite balls, then he used stone, then he used cement, well, whatever, basically, wooden balls. And then he saw that there is this particular ratio which remains constant as long as the pair of the bodies is the same. Like if I take two marbles and collide them, whatever speed they may be, that one particular ratio remains same. Then he tried it with wooden balls. Then he got a new number, but that ratio remains same as long as that pair of the bodies which are colliding are the same. So what is that ratio called? That is called as restitution coefficient or coefficient of restitution. So I can mention it like this: as long as the pair of bodies remains same, the ratio. Now, what was the ratio that he found? The ratio of relative separation and approach. Relative separation and approach remains constant. Now, what is the meaning of relative separation and approach? When do we call separation? After collision happens. While colliding, they are approaching. After the collision, they are separating. So before collision, there is some relative speed of approach. After collision, there is relative speed of separation. That's it. It took just their ratio of that relative speeds, and he found that ratio was a number which was always constant. That's all. So that number is called E. So E is nothing but relative separation. And when does separation happen? After collision. After collision. Upon relative approach. When do you approach? Obviously before the collision happens. Before collision. That's it. That is exactly this number E. That is exactly this number E. Okay. For a pair of given bodies, the relative speed of separation after the collision upon relative speed of approach before the collision. So do not mess this ratio. Do not put afterwards, below, and before on the numerator. Okay. So be very careful about that. Separation is in the numerator. Approach is in the denominator. How do you remember it? Sir, I will get confused, sir, in the exam. I might put this on the top, this below. Think about it. Whenever two bodies collide, they are approaching each other. They will come with full enthusiasm. Yeah, full josh they will come. Once they collide, usually they will lose energy. So after the collision, they will have little bit less energy left. So less speed of separation will be there. So out of these two numbers, separation is usually less, approach is usually the bigger one. So numerator is smaller, denominator is bigger. So this ratio will generally be lesser than 1. So that's how you are going to remember it. E value is less than 1, meaning numerator should be smaller. So who is smaller? Separation. Because approach, they will have full juice, but after colliding, they will get tired and they will separate with slightly lesser speed. Is that perfectly all right? Everybody with me? Okay. Now, if you take some examples, like right over here only. So there are two bodies which are, going like this. Maybe after the collision, this was before, maybe after the collision, this body started to go like this. And maybe this particular body went maybe like this. Chuma, I'm taking some random things. Okay, let's say this is the final velocity here. This is the final velocity here. And this is after the collision. This is after collision. So in this particular example that we have drawn, okay, in this particular example, what would be the value of E? Let's think. Separation means this one. It should come in the numerator. So two bodies are separating. They are going in the opposite directions. If the directions are opposite, what is the symbol of opposite? Like this, the cross. Rotate the cross. How does it look like? Plus. So just add them. So it will be nothing but V1 plus V2. Okay, let's now go to before, that is approach. So this is approaching, M1 is approaching M2 like this. So M1 approached like this and then it went like that. Okay, separation was opposite direction. So M1 approached and then they collided and they went like this. So approach, directions are same. Same means equal to. The symbol of equal to is like this. Join the hands, it looks like a minus, equal to symbol. Join the hands, it looks like a minus. So that means subtract them. So just put U1 minus U2. I've seen so many teachers and students remembering some shitty formula like V2 minus V1 upon U2 minus U1 with a minus sign outside or minus sign inside. Sir, was it U1 minus U2 or U2 minus U1? Sir, was it V1 minus V2 or V2 minus? I'm like, really, guys, why do you remember such random formulas? Not needed. Don't you know relative speed? You have learned it. Just make sure each number is positive. Both numerator and denominator are speeds. Yes, both numerator and denominator are speeds, and speed is the modulus of velocity. And modulus of a number is always positive. So it's not that the ratio is alone positive, but individually the numerator and the denominator have to be positive. Are you getting it? Individually, both numerator and denominator individually are positive. So obviously the ratio has to be a positive number. Yes, great, awesome. Shivesh, definitely. Can you put sessions on? I had done Erodo problems last year also, or maybe even last year, but I got very poor response. Students were like, "Sir, we are not able to understand so much. Sir, it is very difficult. I'm losing confidence," and I got very less views on that. So it was very disheartening because I put so much of effort on it, and I think I've taken one class or two classes on that. So if you guys show that support and strength, even now when I am doing advanced classes, even now today, even Diksha ma'am and even now I'm seeing Namrata ma'am also taking classes on advanced. Even last week also I took an advanced class. Views are very less. So it's like students have already given up. I feel very bad when I see that. When you are watching and preparing for JEE, I mean, it should be like advanced classes should get more views, not mains classes. Okay, so I want to see that enthu, guys, in all of you. Yeah, cool. Yes, perfect. Yeah, definitely. Rodov is one of the best books, especially for mechanics and a little bit of fluids here and there, and maybe even thermo. It's very important that you solve them, and even a little bit of electromagnetism as well. Okay, cool. So let's understand in the context of types of collision, how will this restitution change? Okay, let's go to perfectly inelastic collision. Think about it. What might be the value of E? What might be the value of E for a perfectly inelastic collision? It's very obvious that relative separation will be 0. Relative separation, relative separation is to be 0. Why? Because, where did it go? Why relative separation will be 0? Because they will stick to each other. So there is no separation only. Both the bodies will move together. So numerator is 0. So even the ratio will be 0. Is that right? So the value of E will be definitely 0 for a perfectly inelastic collision because they stick and move together with maximum energy loss. But if you talk about just inelastic collision, there is some loss. So separation will be less. So relative separation is less than relative approach. So that is the reason why the value of E will be less than 1. E will be less than 1, but it will be more than 0. Okay, keep this in mind. The value of E will be more than 0, but it will be less than 1. Here the value of E will be perfectly 0. Is that okay, everyone? And in the best case scenario where it is a good elastic collision, no energy loss, they will approach and rebound with same relative speed. So relative separation will be relative approach. There is no energy loss. And as a result of it, the value of E will be 1 because numerator and denominator will be same. Numerator will be same as the denominator. They will approach with the same speed, rebound, repel with the same speed. So the value of E will be perfectly 1. Is this absolutely clear? Everybody with me on this? Shall we go ahead? Yeah, perfect. Let's solve some questions now on this. Let's solve some questions. Say for example, I'll just draw the scenario. There is a mass m. It is moving like this with a speed u, and there is another mass of 3m which is coming like this, maybe 2m, which is coming with a speed of, let's say, 2u. Okay, this is all before the collision. This is all before the collision, and it is also given to me that the value of E is 0.5. Can you find what happens over here? Can you find what happens thereafter in terms of how much energy is lost? What are the final speeds? Everything. Okay, just try to figure out everything, what might happen later on after the collision. So let's try it out. So first of all, let me draw the scenario. So after the collision, this mass m is here. This is 2m. This masses will collide like this and they will go like that. But I can sense something. This mass is heavy. This is also more speed. So I'm guessing it will move towards the left side. How many of you are able to feel it naturally? This is heavier mass. This is larger speed. So it's like a tiny particle coming with small speed versus a big particle with big speed. So after the collision, I think both of them will end up going this way. Kind of makes sense, right? So even if you assume the other way, no harm. But this is very natural, I mean, to me. V1 and V2 will be like this. Kind of clear? Yeah. Kinematics, Kalavani, I have already taught, bro. Yeah, just check out the channel. I hope you have seen the channel right over here. See, this is, where is it? Class 11th playlist. Can you see kinematics? It's there over here in the playlist itself. Right from units and dimensions, basics of physics, areas, everything is there. Okay, relative motion, friction, Newton's laws, work per energy, everything is there. So you can watch that lectures right over here. It's there in the playlist. Okay. Thank you, Shivesh. So much means a lot, bro. Okay. Now, what can we do? We can apply this formula, but before that, I have a feeling we can apply conservation of momentum. So let's conserve momentum. Let's conserve momentum. Initial momentum is mu, and this momentum is 2m into 2u, but with a negative sign because of the directional nature. And this is minus m v1 because left side, and this is also minus 2m v2. Okay, let's see what do we get. M will cancel from everywhere, so u minus 4u is equal to minus V1 minus 2 times of V2. This will become minus 3U. This will become minus 3U is equal to minus V1 minus 2 times V2. Minus can be taken out. So 3U will be V1 plus 2 times of V2. Is that right? So this is one equation which I have got as of now. I'll just keep it on the sidelines. Now let's think, can we write something else also? Can we write something else also? Yes, we have not yet used the coefficient of restitution. So how about using that? So E is 0.5 and E is nothing but separation by approach. E is nothing but relative speed of separation, relative speed of approach. So what is separation? Let's look over here. This is after the collision. So they collide and they go like this. So after the collision, you can see both of them will be going this way. They are going the same direction, but this speed will be more than this speed, obviously. Or else if this speed is more after the collision, then this will go and again hit that guy. So obviously, after the collision, these two people, this front person should move faster. The behind person will be moving slowly. Else the behind person, this one, if it moves faster, it will again go and hit. So the front person will be moving faster than the person behind after the collision. So they collide like this and they go like that. So V1 and V2 in the same direction. So relative speed will be V1 minus V2. How many of you got it? V1 minus V2, not V2 minus V1. You should think why. Okay, because this person is behind than the person in front. What about before? They both are going the opposite directions. Opposite means cross, plus means add them. So this will be U plus 2U, of course. And this E is nothing but 0.5. 0.5 means half. So this is just half is equal to V1 minus V2 divided by 3U. Cross multiply. So that's why we will get 3U is 2V1 minus 2 times of V2. This is my second equation. Now look at this equation versus this equation. See what we can do. I can see 2V2 here. I can see minus 2V2 here. It's kind of obvious that we should add both 1 and 2. So let's add equation 1 and equation 2 and see what do you get. On the left hand side, we have 3U here also. We have 3U here also. So it will become 3U plus 3U is equal to, here we have V1 plus 2V2, V1 plus 2V2 plus this guy, which is 2V1 minus 2V2. 3U plus 3U is nothing but 6 times of U. 2V2 and minus 2V2 will cancel. That's the best part. So V1 plus 2V1 will become 3V1. 3 cancels. So V1 will become 2 times of U. So I have got the value of V1. Immediately we can find the value of V2 right from this equation also. So using this equation, what do we get? We'll get 3U is equal to 2 times of V1. V1 itself is 2U minus 2 times of V2. So take 2V2 on this side. So 2V2 will be 2 2s of 4U. 3U goes on this side as minus 3U. So therefore it will just become U. Therefore V2 will become U divided by 2. Perfect. We have got the answer. How many of you got it? Yes, V1 is 2U and V2 is U by 2. We have got the final answer. We can also do one more thing. We can find how much energy was lost. All those kind of questions can come, guys. Okay, so let's try to do that kind of question also. But before that, let me show that speeds. How much value we got? We got V1 as 2U. So this is 2U. And we got V2 as U by 2. We got V2 as U by 2 after the collision. Luckily, we got both the answers positive. Say by chance, we got this V2 as minus by chance after solving. What does it imply? It implies the direction that I have assumed is wrong. Magnitude is fine, U by 2 only. Direction is wrong, so V2 is not here, it is the other side. So never bother about the directions what you have assumed. It's okay, assume something. If it comes naturally to you, it's okay. Else, just assume something. And if it is negative, just understand the direction is opposite of whatever you have assumed it to be. Okay? How many of you got it? Understood how to solve the questions using the value of E? Okay. Now, what else kind of questions can come? Let's see this type where once you have got this, how much energy has been lost. So first, let's figure out what is the total initial kinetic energy. it will be nothing but half mu square plus half 2m into 2u whole square. So it will become half mu square plus half 2 square is 4, 4 2s are 8, 8 mu square. 8 plus 1 is 9, so 9 by 2 mu square is the initial kinetic energy. Then we can also find the final kinetic energy, which will be half m into 2u square plus half 2m into u by 2 whole square. So this will become 4 by 2. 2 square is 4, 4 by 2, which is 2. So 2 mu square plus 2 cancels. This will become by 4. So mu square divided by 4. Now LCM will be 4. 4 2s are 8. 4 2s are 8. 8 plus 1 is 9. So 9 by 4 mu square is the final energy. Okay. So from this, we can easily figure out how much is the loss of energy. How much is the loss of energy? So the loss of energy, as you can see, is initial minus the final. Initial is always higher. Initial is 9 by 2 mu square. Final is 9 by 4 mu square. This will become nothing but 9 by 4. Half minus 1/4 is 1/4. So 9 by 4 mu square. That much energy has been lost. Okay, is this clear? So we can easily figure out how much energy is lost, how much was the final, how much was the initial, everything. Now, another type of question can come in this is the fraction or the percentage loss. Okay, this can also be a question. What is the percentage loss of the energy? So percentage loss means how much is the energy which is lost on how much was the initial energy. This will become the fraction. If you multiply it with 100, you will get the percentage. So the loss is 9 by 4 mu square. The initial is 9 by 2 mu square. 9 by 2 mu square, and multiply now this with 100. As you can see, this is 1/4 and 1/2, right? So this will just become half. So it will just become 50%. So 50% of the energy has been lost. Now please don't relate something like this. Sir, if E is 0.5, 50%. If E is 0.7, it is 70% loss. Nothing like that. There is no direct relation. Yes, you can make a formula, it will be very big. But coincidentally, for 0.5, we got 50. For this numerical, if I change the mass or speed, maybe it will not be the same. So don't try to generalize it, because that is a common mistake which many people do. Yeah. Got it, everyone? So these are the kind of questions that you can expect. Let's solve one more question coming up on your screen, and here it is. It was asked in JEE 2021, and it involves 3 blocks. It's crazy. 3 objects are kept in a straight line on a frictionless surface. The masses are m, 2m and m. m, 2m and m. Frictionless, smooth. That means momentum will be conserved. Body A moves towards B with 9, okay, and makes a elastic collision. Keep that in mind. Thereafter, B makes completely inelastic. Wow, there is elastic and perfectly inelastic collision also. All the motions on the same straight line, find the final speed of object C. Okay, so let's try this out. Let's try this out, okay? I don't need this. Read it again carefully so that you understand it. Okay, so let's try to draw the diagram. A is coming towards B with 9 meters per second. So in the first scenario, A is coming towards B with 9 meters per second. This is at rest. This is also at rest. This is the first scenario. After that, what will happen is, observe carefully. Maybe this guy will have some speed, this guy will have some speed, this guy is still going to be at rest. So you will see some new speeds maybe. Maybe this will have some V2 speed, this will have some V1 speed. This is going to be still at rest. Now this will go and hit this person, and they will become one single body. they'll become one single body, and then they will move with a common speed. Let's say that common speed is Vc. That is what is going to happen. So right now they were all at rest, only this guy was moving. This hits like this, and then B is pushed and B hits C, but it is perfectly inelastic, so they become one combined body. Let's write down the masses. This is M, this is 2M, this is M. This was also 2M. When 2M and 2M will meet, it will now become 4 times of M. Okay. Now let's only consider the first scenario, and let's only talk about elastic collision. Elastic collision between A and B. Elastic collision between A and B. So what and all equations can we write? Obviously, we can conserve momentum. So if we conserve the momentum, so conserving the momentum, if you conserve the momentum, here is what you're going to see. If you conserve the momentum, initial momentum is M multiplied by 9 plus this block is at rest is equal to this mass is moving with speed v1, this mass of 2m is moving with speed v2. Let's cancel m everywhere. So 9 will be equal to v1 plus 2 times of v2. Is that clear? That is the first equation we are getting. Now let's use restitution concept. Let's use restitution concept. Let's use this. And we know E should be nothing but separation by approach. E should be separation by approach. So separation, as you can see, after M hits 2M or A hits B, B will go like that. A will be following it. B will be faster than A because after the collision, B has to move faster. It is ahead. Else, if A was faster after the collision, then A will again go and hit B, which cannot happen. So after the collision, B should move faster. So V2 will be more. So V2 minus V1. If V1 was more, it will be V1 minus V2. But I know V2 is more. Before the collision, they are approaching each other with a speed of 9. This guy was at rest. And this value of E, sorry. Okay, what just happened? My God, whatever I wrote went off. I hate this. So sorry, guys. I'll just rewrite. Oh my God. So nicely I had written. Everything went off. Okay, I'll just write it again, guys. So sorry. If I conserve momentum, I'll write 9 m into 9 plus 0 is equal to m into v1 plus 2m into v2. So therefore 9 is equal to v1 plus 2 times of v2. Now if you write restitution equation, E is separation by approach. E is nothing but 1 because it is elastic collision, and separation will be v2 minus v1 upon 9 minus 0. All of this was elastic collision between A and B. Elastic collision between A and B. So if you cross multiply, you will get 9 is equal to V2 minus V1. As you can see, we can add both of them. As you can see, we can add both of them and V1 will get cancelled. So let's add both the equations. Add both the equations. So it will become 9 plus 9 is equal to V2 minus V1 plus V1 plus 2V2. 9 plus 9 is 18. V1 and V1 will cancel. 2 plus 1 is 3. So 3 times of V2. Therefore, V2 will be 18 by 3, which is 6 meters per second, which is what I need for the next part. I don't need V1, so I'll not bother. Now let's consider the perfect inelastic collision, the perfectly inelastic collision between block B and C, between the block B and C. So here we can just conserve momentum and see what will happen. If I just conserve the momentum only, most likely I'm going to get the answer. So 2m into V2 plus 0, because this 2m was at rest, will be equal to combined mass 4m into the common velocity. Now I know what is the V2 value. V2 is 6 is equal to 4m Vc. mm cancels. So 2 6 are 12 is equal to 4 Vc. So VC is 12 by 4, which is 3 meters per second. Is nothing but 3 meters per second. So I think 3 meters per second is right over here as option A. Can you see that? That is the final answer. So beautiful question which was asked, in the previous years of JEE 2021. So two collisions can be put in the same question. So that is the expected length which you can predict for the upcoming JEE 2026 also. Don't expect just, sir, I will get only one thing to solve or two bodies are colliding. That second body might collide with the third body. But as you can see, the good part is one is very good collision elastic and one is very bad, which is perfectly inelastic. So it becomes slightly easier to solve. And if it was just inelastic collision, something like this, then you might get a situation like over here, okay, where you have to be asked, you are asked what is the percentage loss and all of that. Okay, so those are the expected kind of questions. Now there is one more type of question, one more question I think we have. Yes, let's solve that and let's move ahead. An object of mass m1 collides with another object of mass m2, which was at rest. After the collision, the objects move with equal speeds in the opposite directions. The ratio of the masses is how much? Yeah, the ratio of the masses is how much? So test series will be conducted in YouTube. No, Pritija, it will not be conducted on YouTube. How can we conduct on YouTube? Test series. Tests everybody has to give, right? Test will be seen on the screen. Everybody will solve it differently. Score will come. Timing will be noted. Solution will be given. Marks will be allotted. Ranks will be attributed. The analysis will be done. All that will happen online on the platform, right? So that is how it is. Okay, let's draw the situation. An object of mass m1 collides with another mass which is at rest. So let's say this is the speed. This m2 was at rest, and after the collision, they move with equal speeds in the opposite directions. That is crazy. So mass 1 is going like this with speed v, and mass 2 is also going with the same speed but in the opposite direction. So question is, what is the ratio of the masses? I think we can just conserve momentum and see what happens. So let's conserve momentum. Let's conserve the momentum and see what happens. Initial momentum is m1 into u. The other guy is at rest. Here the momentum is minus m1 into v, and the other guy's momentum is m2 into v. Okay, interesting. And okay, collides with another opposite direction. The ratio of the masses is how much? Okay, so now it is not mentioned what type of collision it is. So the ratio of the masses m2 and m1 is, okay, if I need to figure this out, I think the type of collision also needs to be mentioned. I'm guessing I'll have to look at the solution to see if they have assumed it as elastic collision. Yes, it is elastic collision. So I think that part is missing in the problem. It collides elastically. That is missing in the question, else we cannot solve the problem. Okay, so if you assume the collision to be elastic and we use the concept of restitution, E value is 1, separation on the top, approach below. This is the value of E that I will put, which is 1. Separation, check it out, V this side, V this side. So it will be V plus V. Approach is just going to be U. Take it on this side. So U will be V plus V, which is nothing but 2V. So how about using this U over here in this equation and see what do we really get. So let's go to this equation and substitute M1 into U. What is U? U is nothing but 2 times of V is equal to minus M1V plus M2V. Now what happens as a result of it? Check. V over here, V over here and V over here will get cancelled. And what am I left with? 2m1, and this m1 will come over here as plus m1 is equal to m2. So 2m1 plus m1 is nothing but 3m1 is equal to m2, and we have been asked what is the ratio of m2 by m1. So from this, m2 by m1, m2 by m1 will be nothing but 3 by 1. So 3:1 should be the answer, which is option A. Perfect, we got the answer. So elastic collision knowledge we have used, E is 1, separation by approach. The momentum is always considered whether it is elastic, inelastic, perfectly inelastic. That knowledge also we have used. Okay, clear? Perfecto, guys. Amazing. So these are the kind of questions which you can get. And one more good question which I know is this bouncing ball question, where you know you have a surface like this, and there is a ball which is let go. It falls from some height. Let's say I call that height as h naught. You drop it and it bounces because there is some kind of coefficient of restitution E. But when it bounces, it does not bounce till the same height. It bounces slightly lesser, and again it comes back like this. Next bounce, it will not bounce so much, slightly lesser, and again it comes back over here. Next bounce, again the same thing, and this thing continues. So maybe after a few more collisions, n number of collisions, it goes up so much and comes down this much. Can you figure out how will the height change after n number of collision? So it is hitting, going up, coming down, hitting, going up, coming down. Okay, this is what is happening. So can you figure this thing out? Okay, what is the height after the nth collision? So to figure out the height reached after n number of collisions, what is the height which is reached after n number of collisions? We can easily figure it out, and I'll tell you how. Observe carefully. During the first collision, if you ask me, forget all this. So during the first collision, it will hit the ground with a speed of v naught. This v naught, by the knowledge of projectile, is root of 2g height being h naught. After the collision, what happens is the speed will get reversed in the other direction like this. Maybe I will call that speed as v1. As a result of that speed, the ball goes up till some height, reaches there, and again comes down, but the speed will be the same. Whatever speed it goes up with, the same speed it will come down. Is that right? Everybody with me? Pakka? Okay. Is there a relationship between V0 and V1? Answer is yes. So if I use the knowledge of restitution between the surface and the ball which is hitting it, after the collision, the ball is separating from the surface with a speed of v1. Can you see that? It is separating with the surface with a speed of v1. But it is approaching the surface with a speed of v0. So therefore, can I say v1 is e times of v0? v1 is e times of v0. Correct? Okay. Now the same speed with which it goes up, the same speed it will come down. There is no air resistance, so energy should be conserved from here to here. But when it again collides, it will lose some energy. And when it again rebounds, the speed will be slightly even lower. As a result, it won't go so much, it will go slightly less. But again, when it comes back, again it will have the same speed, v2. Now again, if I use the knowledge of restitution, what will I get? This E will be speed of separation. So after collision, the ball separates with a speed of v2, but it approaches the ground with a speed of v1. Therefore, v2 will be E times of v1, but v1 is E times of v0. So therefore, it will be E square times of v0. v2 will be E square times of v0. Got it? So now think logically, my dear warriors. Third time when it goes up, and again when it comes back, it's going up, maybe slightly less height, and coming back like this. This speed will be v3. Can you guess v3 without even doing it? Can you guess v3? If v1 is e raised to 1 v0, v2 is e raised to 2 v0, v3 will be e raised to 3 times of v0. So that means after 4 collisions, 5 collisions, 6 collisions, n number of collisions, after n number of collisions, Vn will be e raised to n v0. Vn will be e raised to n v naught. Cool? Okay. So from this, can we figure out how high does the ball go up and down? Definitely. That height, hn, 1D projectile motion. If you throw a ball up with some height, the maximum height reaches speed square by 2g. It is nothing but speed square, which is Vn square by 2g. This is from vertical free fall motion chapter or topic, vertical free fall motion chapter. So what is Vn? Vn is nothing but e raised to n into V naught, okay, the square divided by 2g. So therefore it will become e raised to 2n V naught square divided by 2g. But wait a minute, I know what is V naught. V naught is a root 2gh. So it will be a root 2gh and squaring it, whole thing divided by 2g. 2g will cancel because the square root will go off by the square. Only h naught will remain. H naught will remain. So hence the final answer will be nothing but e raised to 2n multiplied by h naught. That is height after n collisions. It will be e raised to 2n into h naught. Is that clear? Okay, this is a very good conceptual problem on inelastic collision. Guess what? Yeah, it is an infinite GP. It is a decreasing GP. Okay. Guess what? If E is 1, it means it is a elastic collision. 1 raised to any number is 1. 1 raised to 2, 1 raised to 100, 1 raised to infinity is also 1. So, this number will become 1. So, nth collision will become h naught. Makes sense. Because it will always go and rise till the same height. It will never ever stop. It's not losing only energy. Is that right? So this formula can be put to a test by putting elastic collision visualization. I know if E is 1, it will never ever stop. It will keep on going till the same height. But the moment E is some 0.7, 0.6, 0.4, obviously this number will become smaller, decreasing GP, right? And it will eventually stop after infinite collisions. Yeah. This is a JEE Advanced concept for sure. Yeah. Great. See, you got Insta. Akhil, next year I'm going to see this. Who is this guy? Akhil. Akhil is asking, Lara, do you have Insta? Next year, your parents will be asking you, bro, do you have IIT seat? Then I want to see what your answer is. But maybe I think Lara only will ask you. Forget parents. Lara only will ask you, Akhil, do you have IIT seat? Then that will be a facepalm moment. That will be a clown moment. Okay. So better work hard, man. Be a Sigma out there. Okay. Now let's take some special cases. M1 and M2 will compare the masses for elastic collision, only elastic collisions. Okay. 3 special cases. If 2 masses are equal and they collide, you will see the velocities will get exchanged. Very simple property. Kind of, the velocity, if the masses M1 and M2 are equal. So for elastic collision of 2 equal masses, the velocities get exchanged. Velocities are exchanged. What does it mean? It means, imagine this mass had 7 meters per second. This mass had, say, 5 meters per second. Masses are equal, m and m. Once they collide, you will see this mass now will move with the speed of 5. Okay, this mass now will move with the speed of 5 and this mass will move with the speed of 7. It's like the soul of this body went into this body, the soul of this body went into this body. It's like the souls have got interchange where the souls represent velocity and the body is basically the mass. So the bodies which are moving with the bodies which collide elastically and having same mass, the velocity of this goes into this and the velocity of this goes into that. The velocities get exchanged if masses are equal and it is elastic. Okay. Yes, subtopic list I will give you by tomorrow. Okay. Yeah. Next. Important. If one of the mass is very heavy, imagine it's like an elephant and one dog is coming running. Bow, 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 bow. It is coming and it is going and hitting that elephant. Do you think the elephant will move? No, right? The elephant will still be the same. But the dog, if it has jumped and hits that elephant, it will rebound back with the same speed. So you will see the smaller mass rebounds with same speed, and the very heavy mass, is still at rest, is still going to be at rest. Kind of makes sense. So if this guy was going with some speed u, this guy will still be at rest. This will still reflect with that same speed u. If this guy's speed was 0, this guy's speed will be 0 here also. Okay, it will go and hit like this and come back. Speed of approach will be speed of separation. Very easy to understand. The last one is the tricky one. Imagine there is a dog chilling out, just lying down. One big elephant comes running towards that dog. This is that elephant coming running towards the dog. That elephant jumps onto that dog in air. Maybe the dog is lying in air somewhere, gravity free space. Hits the dog. The elephant will continue with the same speed, being so massive that dog will fly with double the velocity. Okay, that is very, very important. So the elephant speed is u. U afterwards also. The dog was at rest. The dog was at rest. But after the collision, the dog will have double the velocity, okay, of the elephant. So the smaller mass has double the speed. The heavier mass continues with the same speed. The very heavy mass has same speed, but the lighter mass has double speed. Okay, very, very important. Has double speed. Okay, clear, guys? Perfect. Yeah, for this, your teachers derived one big formula and all of that. I'm telling you, like, really, you need a derivation for this. I think it is more like common sense. Yeah, isn't it? Like elastic collision, speed of approach should be speed of separation. So if somebody applies elastic collision separation by approach, I know E is 1 because it is elastic. Separation is U. Approach is U. U by U is 1. Common sense it will be, right? And here also, like if I apply E value, I know it is 1. What is the speed of approach and speed of separation? Speed of approach is U minus 0. U minus 0. What is the speed of separation? It is 2U minus U. So you can see it will just be U by U. Yeah, it will just be U by U. Okay, it will just be U divided by U, which is 1, which kind of makes sense for the value of restitution. It is elastic collision. Yeah, so that is why it is double. There is nothing to derive so much because JEE is all about common sense. Okay, so keep all these things in mind. All right, so now let's go to oblique collisions. Oblique, we saw head on, everything was 1D. Now this is oblique collisions or 2-dimensional or 3-dimensional collisions. The only difference is it's not just 1-dimensional, it's 2-dimensional. So whatever you did in 1D, you have to do it in 2D. And one small change in the formula of E. I'll tell you what it is. Don't worry. Example first. Oblique collision means, imagine this is a pool table. This is your striker ball. This is your stick. You're aiming like this. And that ball goes and cuts this ball at rest over here, or maybe moving ball, whatever. It hits like this at an angle. This ball goes there. This ball goes here. Sometimes the pocket might not be directly in the front where you want to put that ball. So that is why you will cut that ball at an angle. So it hits like this and this ball goes here and this ball will go somewhere else. So that is oblique collision. It's like also maybe there is a junction. One car was coming from here. Another car was coming from here. And both these cars meet at the junction. They did not see the traffic signal and they collide and they will go somewhere. Oblique collision. There is one nuclear missile which has been fired by some country. India recognizes that missile. India also launches that missile and they both collide midair and they both go somewhere else and they land in some other country. Oblique collision. Understood, guys? So this is the meaning of two-dimensional or oblique collision. So does a perfectly inelastic collision always mean that the bodies have to stick, or there is an exception? Very excellent question, Gokul. I will answer your question today in this 2D collision. 2D collision has an exception. Not in 1D. 1D stick does not mean necessarily they are attracting each other. That can mislead many kids. When we say stick, it means they move together. Okay. But in two-dimensional collision, they need not stick to each other. Okay. And I will show you why also in a bit. It's a very interesting example. In 1D, they will move together. Sticking is not mandatory. But if it sticks 100%, it is inelastic. But they should just move together for a head-on 1D collision. Okay. Is that fine, Gokul? Yes, I do remember. Madras Medical College, very good, Sai. I'm so glad. Yes, I do remember your name. All right, it's home. Perfecto. Pritija, what do you think? Test series will be free or not? You only tell me. You only tell me. Pritija, I want to ask you one question. You want to earn money. So tell me, how will you earn money? Okay. So this is one dimensional. This is oblique collision. One dimension, everything is happening in one line. In two dimensional, it will happen at an angle. Now, now, let me tell you one very important thing. Say, for example, these are the two bodies which are colliding. This is during the collision, maybe. Maybe this is okay. This is coming like this. This is coming like this. And then they collide with each other like this. This is their common normal. And then this is here. Maybe this is so there are two bodies which come like this, collide, and after the collision, maybe this goes like that somewhere, and this will go somewhere here. God knows. Okay, this is after the collision. So there are three different scenarios. This one is before, this is during, this is after the collision. Now let me also mark their velocities over here. Maybe this guy has some velocity u1, maybe this guy has a velocity u2. After the collision, maybe this guy has a velocity v1, this guy has a velocity v2. If you just conserve the momentum, if you just conserve momentum, if you just conserve the momentum, you can definitely say m1 u1 bar plus m2 u2 bar is m1 v1 bar plus m2 v2 bar. But you can also split this equation in x and y direction like this. m1 into u1's velocity in x direction plus m2 into u2's velocity in x direction is equal to m1 into v1's velocity in x direction plus m2 into final velocity of 2 in x direction, in two components basically. And same thing in y direction, m1 into first mass's velocity in the y component direction, second mass into initial velocity in the y direction is first mass into final velocity in the y direction plus the second mass into final velocity again in the y direction. So if you want, you can just split it also. Okay, if you want, you can split this equation into two parts in x and y if required, or else you can just solve it in I, J, K or whatever. But this is just one of the things. We need one more equation, and that is restitution. So I've seen this with many kids out there, and I asked them what is the value of E, and believe me, 99% of the kids do not give me the right answer. They say it is V2 minus V1 upon U2 minus U1 because they are biased at such things. Tell me one thing, how can I subtract V2 with V1 or even U2 with U1? Because they are in different directions. Oh, yes, sir, you are right. Sir, so I will do one thing, sir. I will do V2 minus V1 and I will do it vector wise and then I will take the modulus. That is also stupidity. Don't do V2 bar minus V1 bars mod, U2 bar minus U1 bars mod. That is also wrong. So that is also wrong, sir. So then what's correct? That is why this diagram is important. You should always show what is happening during the collision. I bet it that many of the kids would not be even taught this in the class, the 2D collision part, and how it has to be drawn or taken. During the collision, draw the diagram and show the forces acting on each other in which direction, not the exact value, just in which direction they will apply forces on each other. The direction of forces will be along the common normal. So this line is usually the common normal. Normal means perpendicular. Common tangent means this is common tangent. You would have learned these kind of things in your conic sections and coordinate geometry. Common normal, common tangent, right? So common normal means wherever the curves intersect. Okay, if you can draw perpendicular, that is common normal. Wherever the curves are meeting, if you can draw a tangent to both of them, that is common tangent. So right now, common normal, because the force will always act perpendicular. Normal force, imagine two surfaces are in contact with each other. This is surface 1, this is surface 2. This surface will apply a force on this like this. This surface will apply force on this like this. This is how the forces are. And if you extend it, you will get the common perpendicular. If you extend it, you will get the common perpendicular. So choose the velocities. U1's velocity along the common normal, U2's velocity along the common normal, V2's component along the normal, V1's component along the normal, and that relative velocity is what you have to take. Understood? So it is the relative separation upon relative approach, but the catch is along the line of force of collision, along the line of force of the collision. So you have to take all the velocities in this line. Okay, so if I draw this particular line like this, and if I show the velocities, like for example, u1 is like this, I think u2 is like this. Okay, chumma I'm just showing like this, u1 and sorry, this is u2. You are going to take this component, u1's this component and u2's this component. As you can see, both of them are approaching each other. This is approach. This is relative speed of approach. This is approaching each other. Same way, if you consider over here, after separation, how are they going exactly? Well, V1 is like this, maybe slightly, and V2 is somewhere here, I think. So I'm showing randomly. Okay. So this is maybe V1. This is, let's say, V2. Take their components again. Take their components again. V1 will have some component over here like this. V2 will have some component over here like this. Now this is basically your separation. Okay, this is separation. Forget the orange lines. Just consider the green lines. They are separating away from each other. Here they were approaching. So take their ratio. That will give you the value of E. How many of you understood it now? How many of you understood it now? Online, Nenavant, no point giving offline. JEE exam is no longer offline. Long time back it was converted into online. You should be having the idea of it. Okay, perfect. Clear? Yes, awesome. So let me show you an example, a simple one first, and then we'll go to the complicated one. Okay, so let's take this example. Particle A of mass m1 moving with some velocity collides with another mass of some rest, okay, velocity v1 and v2 be the velocities of the particles A and B after the collision. Since m1 is 2 m2 after the collision and v1 is this much, what is the angle between v1 and v2? Interesting question. Two masses, two velocities given before. After the collision also one of them is given, other velocity is not given. Angle between v1 and v2 is asked. I feel first let's figure out what is the velocity and then we'll proceed. So can we say m1 u1 bar plus m2 u2 bar is equal to m1 v1 bar plus m2 v2 bar. This is pretty much standard which we have seen in two-dimensional collisions. So let's substitute. M1 is 2 times of M2. So 2 times of M2 into U1. What is U1? Root 3 I cap. Root 3 I cap plus J cap. Okay. Plus second mass M2 was at rest. It was clearly mentioned. So into 0 is equal to M1 is again 2 times of M2. M1 is 2 times of M2. What is V1? I cap plus root 3 J cap. I cap plus root 3 J cap plus M2 into V2 bar. As you can see, M2, 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 M2 will cancel out everywhere and I am left out with 2 root 3 I cap. 2 into J cap is 2 J cap is equal to 2 I cap and we have 2 root 3 J cap plus V2. So if I just want V2 bar, then take these two people on this side. So it will become 2 root 3 I cap minus 2 I cap plus 2 J cap minus 2 root 3 J cap. Therefore, my velocity will become 2 root 3 minus 1 I cap plus 2 again 1 minus root 3 J cap. So we have found out the value of V2. Okay. So now what do we do? Now what do we do? We have to find the angle between V1 and V2. We have to find the angle between V1 and V2. How do we find the angle between any two vectors? You have to take the dot product and divide it by the magnitudes and all of that. So let's do that. Cos theta will be V1 bar dot V2 bar, the dot product, upon magnitude of both the vectors. Okay, what is V1 dot V2? V1 final velocity is this one, which is I cap plus root 3 J cap. Dot product with V2, V2, V2 is this. My God, this is such a big number. So what is it? 2, actually 2 is common. So 2 root 3 minus 1 I cap plus 2 1 minus root 3 J cap. Okay, big bracket. Whole thing divided by magnitude of the first vector. Magnitude of this vector will be root of 1 plus root 3 square means 3. Is that right? Multiplied by magnitude of this vector again. Wow, crazy. So root of, okay, 2 will anyways come outside, so forget it. Root of root 3 minus 1 square, root 3 minus 1 whole square plus 1 minus root 3 whole square. 1 minus root 3 whole square. Is that okay? So that is what you need to do, guys. And now solve this. It will just take you a couple of more minutes and just do the math and you'll get the answer. Anyways, I cap into I cap is 1. So the first term over here will be 2 root 3 minus 1. This into this means plus root 3 multiplied by 2 multiplied by 1 minus root 3. The whole thing divided by 1 plus 3 is 4. 4's root is 2 and this 2 is also there and then everything inside the brackets. a minus b whole square, a square plus b square minus 2ab. So 3 plus 1 minus 2 root 3 plus 1 plus 3 minus 2 root 3 and all of that. Solve this and you are going to get the answer finally as 105 degrees. Okay. So you will get the answer as 105. Basically 90 plus 15. 90 plus 15 will be 105. So you will get it in terms of cos 15. Cos 15, remember? Yeah, same way you will get it. Is that clear, everyone? Sir, how we attend MVSAT? Is there any hall ticket? You will get the registration. Once you're registered, I think you will get a hall ticket and a number, registration ID, whatever. So with that same ID, you will have to enter the examination hall. Hello, Zayan. Welcome. Yes, I hope this is clear how to do it. Okay. One more example I'll give you. One more example I'll give you. It's very nice. And this is what I was talking about. Somebody had asked, does that mean that two bodies should stick if it is perfectly inelastic? So this is a very good example of that. So imagine, yeah, there is a surface over here. It has a restitution E and this is the perpendicular drawn. Now what happens is there is a ball which comes and hits it like this over here and it rebounds like this. Okay, and it rebounds like this. This is the angle of incidence. This is the angle of reflection. The ball comes like this, hits like that, reflects. Lot of you will say angle of incidence will be angle of reflection. Well, that's true for light, but not for balls mechanically, because some energy will be lost. So when it hits and rebounds, some energy will be lost, and I don't think the angles will be equal. Can we figure out a relation between incident angle, reflected angle, and the restitution? The answer is definitely a yes. So let's see how do we do it. First of all, let's think what kind of force will be applied on mass m. When this mass hits the surface, obviously there will be a normal force which will be acting like this. There will be a normal force which will be acting like this, but there is no force in the horizontal direction. So I can say net force in x direction is 0. Therefore, momentum is conserved. Momentum is conserved in x direction. Momentum is conserved in x direction. Correct? Everybody agrees to this statement? Okay. Gautami, I'm not sure if that is the case, but let me check with the team. Can you just put up a comment after the video ends so that I can respond to you? Because in the live chat, the chat will go away. But after this video ends, if you put a comment, it will stay. Okay. So that I can remember your name and I can respond to you after the live is over also. So what is the momentum in x direction? So we'll have to split the velocity in two ways. This is x, this is y. Here also in y direction and in x direction. Okay, but before splitting it off, let's understand the angle. If this is I, obviously this angle over here will be I, and after reflection, this angle over here will be R. So velocities will be, if this is, for example, I'll assume this velocity as u velocity, and let's say I will assume this as some new v velocity. This will be u cos I, this will be u sin I, this will be v cos R, and this will be v sin R. So to conserve the momentum in x direction, consider x velocity. So the mass into x velocity, which is u sin of I, will be mass into final velocity, mass into v into sin of R. Therefore, u sin I will be v sin R. That's all I am getting. Nothing more, nothing less. Now let me think of restitution. Restitution says E will be relative separation along the normal upon relative approach again along the normal or that line of force. So think about it. What is the separation along the normal? This is a normal force. Along that normal, the velocity is cos r, v cos r. So this will be v cos of r from this surface. This mass approaches this surface with a velocity of u cos I along this normal. So this will be u cos of r. So therefore, from this, we can say u cos r multiplied by E is equal to V cos of R. Now let's divide both of them and see what do we get. So let's divide both of them. So we will have U sine of I divided by U cos R multiplied by E is equal to V sine of R divided by V cos of R. U gets cancelled, sine by cos is something I went wrong. This was not u cos r, this was u cos I. So sorry. Cos I. Yes, this was u cos I multiplied by E. Yeah, is that fine? U cos I. So same thing over here also. This will be u cos of I multiplied by E. U will get cancelled. Sine by cos is tan. So it will become tan of I divided by E. VV will get cancelled. This will just become tan of R. Therefore, E will become tan of I divided by tan of R. Perfect. Amazing. And I feel we should remember this for solving questions. Direct questions have come previously in the examination. E is tan of I by tan of R. E is tan of I by tan of R. So what it means is, imagine we take three cases. Imagine we take three cases over here. First time, let's say E is 1. Next time, E is less than 1. Next time, E is basically 0. Okay, this is perfect inelastic collision. And this is just a elastic collision. If it is elastic collision, E is 1, tan of I and tan of R will be equal. That means I will be equal to R. So you will see that in the first scenario, with whatever velocity and angle it comes, the same velocity and angle it will rebound. So this angle of incidence will be equal to this angle of reflection. But if E is less than 1, that means a regular inelastic collision. So this will be like 0.7, 0.6 like that. So the ratio is less than 1. That means denominator is bigger. Denominator is bigger means tan is bigger. Whose tan is bigger? Whose angle is also bigger. So R will be bigger than I, and you will see it will rebound with a larger angle. So it will look something like this. It will come probably like this at a smaller angle, but the reflected angle will be more. So this angle is small, this angle is higher. And in this case, what will happen? It is going to come and hit over here. E is 0, that means numerator is 0 or this is infinity. But I know numerator is not 0 because there is some incident angle definitely over here. There is some incident angle over here. So numerator can't be 0 if E is 0. So only option left is denominator is 0. Infinity. That can only happen when R tends to 90 degrees. So the reflected angle will be almost 90 degrees like this. So it will be perpendicular. So even if it is perfectly inelastic, it will hit and it will go like this. It feels like it has got stuck, but it already has some horizontal component. It will maintain that component because x direction, their momentum should be conserved because of no force, right? So the velocity will continue over there. So it will move like this by sliding. So it's not really stuck to it. Is that clear? Yeah. Mind fuel, definitely, man. You can definitely join the Moria batch right now. Perfect. So these were some questions on two-dimensional collisions. I hope you loved these examples. They are really super duper amazing. Yeah. So I have kept a homework question for all of you. Please try to solve it. It's very straightforward. Okay. It's like there is a ball and it is on a height. One bullet will come and hit the ball. So now they will separate because they will move separately. This ball was at rest. It will hit like this. Now the bullet will go and fall somewhere. The ball will go and fall somewhere. So depending on where they fall, you can retrace what was their original speed, once the bullet struck the ball. That speed you can use to find out with what speed was the bullet actually hitting the ball. Okay, so you have to find the speed with which the bullet hits the ball, because after that they will go and fall somewhere. So if you know the range, you can figure out what was their speeds. That will be the speeds after the collision. From that, use conservation of momentum, whatever, and figure out the original speed of the bullet. It's combination of projectile and collisions. Okay, answer is there on the next slide. PDF will be shared with you shortly in the description box, and in the comment section it will be pinned. Okay, make sure you're registering for MVSAT also. All right, thank you guys very much. Hope you have liked the video. If you have forgotten, please do that and subscribe to the channel. Let's make it 300K. Okay, bye bye. This is Captain Shreyas signing off. Hasta la vista.